Righto, this is a set of worked examples for Edexcel IGCSE. This is courtesy of Save My Exams. It's their Gold P2, so quite a good set of questions. So let's go straight in. Question 1, player buys some shares for $50x and sells them for 600 plus 5x. She makes a profit of X%. Show that x squared plus 90x minus 1200 equals 0. Okay, so in this occasion, obviously we're forming an equation in x. That kind of implies that we've got the same information expressed in two different ways in the question here, and that certainly is the case here. What we need to be thinking about is the growth factor. So the growth factor, if we're investing some money in a bank at 3%, then the growth factor would be the value of the money at the end of the period divided by the value of the money that goes in. If we're actually in business, it might be the amount of money, amount of sales divided by the cost. So that's what we mean by the growth factor. And if the growth factor is 3%, then if the increase or the profit or the interest is 3%, then the growth factor would be 1.03. So that's what we mean. So if we look here, this is the sale price of these shares. This is the cost price. So this is the growth factor. And then the other way of looking at the growth factor is this. So this is like maybe the 3%, 3 divided by 100, that would be 1.03. So that's another representation of the growth factor. So so another way of writing this, we could say, is find two ways of stating the growth factor. So we've done that, and we've made them equal to each other. A bit of algebra, really. We just have to get a common denominator here, cross multiply, and let's multiply out and simplify, and we end up with this statement, which is what they're asking for. And if you're not convinced of that, just pause the video and you can see for yourself. It then goes on to say, solve this equation, and it also says find the value of x correct to 3 significant figures. Actually asking if it's two slightly different things there, and we'll see that in a moment. Okay, so the way I've chosen to do this is by completing the square. So if we consider this expression here, x plus 45 all squared, that's going to give us x squared plus 90x, twice this, but it's also going to give us this squared here as well, which is 2025. So we need to subtract that off. So this expression now is the same as these first two terms here, and I've added 1200 to both sides of the equation. So that gives us this, which, taking the square root, gives us x plus 45 equals plus or minus 56.79. Okay, so this next line, x equals minus 45 plus or minus 56.79, you would say is the solution. Actually, two roots, aren't there, to the equation. However, we're searching for the value. Now, I think it's reasonable to assume that x is going to be positive. Suppose we could imagine that we could buy some shares for a negative price, but here it does say the value. So I think we could reasonably assume that that is positive. So we're going to take the positive root here, and that's going to give us, well, minus 45 plus 56.79 will be 11.823 significant figures. Okay, so that is that one. Now, this number 2 is 3D trigonometry, one of the trickier types of questions at GCSE, I think, and the reason for that is that these are quite often difficult to visualize. This one's not too bad. It's just a cuboid. It's drawn out sides 3, 5, and 7, and then they've dotted in the diagonal here. Okay, so it says calculate the length of AG to 3 significant figures. Now, very often with these things, well, nearly always actually, the thing to do is to draw in these extra lines, usually along a particular plane, and that's what we've done here. So this ABC, triangle ABC, is a right angle triangle. This is a right angle here, this angle ABC here. If you can imagine looking down on the triangle, then that's what you would see. So we can then derive AC from Pythagoras' theorem. AC squared equals AB squared plus BC squared. Well, we're not going to work that out just yet, because we are actually after AG, and we can apply AG, particularly this triangle ACG. You can probably see that this angle C here, ACG, is also a right angle. So we've got Pythagoras again, AG squared equals AC squared plus CG squared. But of course, we've got an expression for this, AB squared plus BC squared. So we can just write that out like that. Now we can substitute our values in 3, 5, and 7. And we work that through, and then take square root to give us AG, and that's 9.11 centimeters, 3 significant figures. That looks about right, isn't it? This is 7 here, so that, yeah. Right, and then it says here, calculate the size of the angle between AG and plane ABCD. So again, we've got, what one is this angle? We want an angle which is kind of perpendicular to this plane ABCD here. So hopefully you can visualize that angle there being the angle that we need. Now we've got all 3 sides here. I've taken the sine, so the sine of this angle is going to be the opposite CG over the hypotenuse AG, or we could say the angle is the inverse sine of CG over AG, which is the inverse sine of 3 over 9.11, giving us 19.2 degrees. That's our calculator. Right, so that's number 2. Number 3 is surds. Express square root of 48 plus the square root of 108 in the form k root 6, where k is a surd. Now this is slightly unusual because we're used to seeing these things where k is a whole number, but here it's actually a surd. So we've got a surd times a surd involved in the answer to this. So let's have a look. Square root of 48 plus the square root of 108. Now we want to factorize out root 6 here because that's part of the answer. So that'll be a good idea. But it's also a good idea to actually factorize out any square numbers as well, because we can take those out of the bus shelter. So that's what we got. Root 48. Square root of 48 is square root of 4 times 2 times 6. 108, 9 times 2 times 6. So we can put these bits in their separate bus shelters. So square root of 4, well, we'll just write that as 2. Square root of 4 times root 2 times root 6 plus 3, which is the square root of 9 times square root of 2 times square root of 6. So that's 2 root 2 times root 6 plus 3 root 2 times square root of 6. So that's altogether it's 5 root 2 times root 6. So that is our answer, and giving us that k is equal to 5 root 2. Okay. Right, okay, so this next one is a vector geometry question. So if you're not sure about the principles of vector geometry, then I suggest you go and have a look at my vector geometry video. So let's have a look at what it says. The diagram shows a trapezium PQRS, yes, because 2 sides are parallel, so trapezium. PS equals 4QR. Now this is a geometry statement. It's just saying that this length PS is 4 times this length PR. But because we have a vector value for QR, then we can basically say that PS has a vector value which is 4 times that of QR. Okay, so PQ equals A and QR equals B. So that's what we've got there. Find in terms of A and B, PS. Okay, PS, well, we've just done that. Really, haven't we? PS equals 4 times QR. QR is B, so that's 4B. Next, PR. Okay, PR. Now we can do an expansion on PR, and the idea is to expand it in order to get it in terms of things that we know. So this is the expansion. Now, how do we know it's the expansion? Well, because these Q's in effect cancel each other out. So if you imagine those, all that kind of middle bit sort of falling away, then we can see that PR equals PQ plus QR, and PQ equals A, we're given that, QR equals B, we're given that, so PR is going to be equal to A plus B. And then finally RS, well, RS here, well, let's expand that. I mean, really what we're doing is we're finding ourselves an alternative route for getting from R to S. We're going RQ, QP, PS. RQ plus QP plus PS, and you can see that cancellation thing applies twice here. Now RQ is QR in the opposite direction, so we change the sign. So QR equals B, then RQ is minus B. That's what we've got there. In the same way, QP is minus A. PS is what we found it to be in part 1, which is 4B. So that's a total of 3B minus A. So as with a lot of these vector geometry questions, there's a part A and a part B, and usually the part A's are pretty straightforward. So it's worth understanding the principles and being able to apply them just for those 3 marks, even if you don't go on to do part B. However, part B isn't really that awful either. So let's just have a look at that. The diagram shows a trapezium. There we go. The point T lies on the line PR such that PT to TR equals 4 to 1. PT to TR equals 4 to 1. So that also means that PT is 4/5 of PR and TR is 1/5 of PR. It's turning our ratios into fractions, basically. Given that TS equals KQT, find the value of K. So really what we need to do here is we need to express both of these things, both sides of this equation in terms of the algebraic values, A, B, and C, just A, B in this case, and then compare them. Okay, so TS equals TR plus RS. So we're going to go this way, TR down to RS. And TR, well, TR, I just said before, it's 1/5 PR. We know the vector value of PR. So it's going to be, which is A plus B. So TS is going to be this expression, which simplifies to 4/5 into 4B minus A. Okay, what about this right-hand side here? QT, well, QT, so QT, well, what we're going to do is we're going to go QT is QR plus RT, and RT, go the opposite direction, it's TR, which would be minus RT, so we've got QR minus TR. Okay, QR we know is B. TR we just worked out above, didn't we? It's 1/5 of PR, so it's 1/5 of A plus B. So it gives us, when we simplify this, we're going to get 1/5 into 4B minus A. Now we can see therefore that TS is 4 times QT. TS equals 4 times QT. So K equals 4. Okay, so again, not too difficult. So, we just have to understand our rules for, expanding vectors, going down, effectively going along a different route to get from T to S in this case. and also scalar multiples where lines are parallel, and it comes out fairly well. Right, okay. A bag contains 60 beads. X of the beads are red and the rest are green. Altaf takes a random bead, a bead from the bag. Okay, state in terms of X the probability that he takes a red bead. Well, there's X red beads out of 60, so quite simply, it's X 60ths is the probability of a red bead. Now he puts his bead back. Okay, another 20 red beads are added to those in the bag. Probability that he takes a red bead is now doubled. Okay, so the probability now is going to be, well, there's 20 more red beads and there's 80 beads in total. So this is the probability of getting a red bead when drawing as a random. Now, after the addition of the beads. And we are told, this is a sort of the key equation, the probability that he takes a red bead is now doubled. So this new probability is going to be equal to 2 times the old probability. So there we've got our equation in X. We can just rearrange that and we come up with this as directed by the question. And then the last part says down here, solve. So we're just going to solve this as a linear equation. Nothing particularly to do with probability. X equals 12. Right, so that is that. Now here we've got another forming equation problem, but this one is going to involve a little bit of differentiation. So we've got a rectangular photo frame, area A, X by Y, and the perimeter is 72. Show that A equals 36X minus X squared. Right, so in this case, we've actually, because we've got two unknowns. So we're going to expect there to be some way of eliminating one. Well, we've got to be able to eliminate Y in order to form this equation, and we can certainly do that because we use the perimeter statement here. So this is the perimeter, isn't it? It's 2 times X plus Y, 2X plus 2Y equals 72, and we can rearrange that to Y equals 36 minus X. So now when we look at the area, it's going to be X times Y, but we've got a substitution for Y. So we can take this 36 minus X and put it into there, and then when we expand that, we get A equals 36X minus X squared as directed. Right, now it goes on to say find dA dx. So this is the rate of change of the area with respect to X. So it is actually, if we draw the graph of A against X, it is actually the gradient. Well, it does depend, it does vary with X. So it itself is a function of X. So if we differentiate A with respect to X, we're using the power rule. That's going to give us dA dx equals 36 minus 2X. And now go on to say, find the maximum value of A. Right, well, this function here is a negative quadratic, so that's kind of shaped like a hill. The maximum value is the Y value at the top, and that occurs for a value of X. We want the maximum value of A. So now the thing to note here is at this turning point, so this, when we've reached the maximum, because what happens is as we increase X, then we get an increasing area up to a certain point, and then it starts decreasing. So we want that value of x that represents the maximum value. And at that maximum value, if we were to draw it and draw the tangent at the maximum value, well, of course, it's going to be horizontal, and that gradient would be 0. So at the turning point, the maximum value is, or the gradient, I should say, is 0. So we can take this fact and squish it together with this one. So 36x minus 2x is the gradient function, equals 0 at the point that we're interested in. So 36 minus 2x equals 0, giving us x equals 18. Okay. So the actual maximum value is going to be 36 times the value of x at the maximum minus 18 squared. This is 2 times 18 squared. So that's why I've just rewritten it like that. Perhaps slightly easier. And that's giving us 324 square centimeters. So that is that one. Okay, maximum value is 324 square centimeters. Now, it's interesting, isn't it, that the maximum value is at 18, because when it's 18, then if we just roll that again, if that's 18, then the value of y must be 18. Now, that's intuitively obvious, really, because if we had the maximum for a different value of x, and we could have swapped x and y over, and we would have a bit of a contradiction. So it's kind of intuitively it's correct. Right. Now, number 7, 2 small magnets attract each other with a force F newtons. F is inversely proportional to the square of the distance d between them. Now, don't be put off by the fact that we're talking about a bit of physics here, and because with these things it doesn't actually matter. We're just looking at a mathematical relationship inversely proportional to the square of the distance. So F is proportional to 1 over d squared, and therefore we can write, if we put in our constant of proportionality on the right-hand side, F equals k over d squared. So that's a sort of a raw equation, but this isn't a useful equation until we can actually find what the value of k is. And in order to do that, well, we need a boundary condition. So we've effectively got one unknown in this. We've got a relationship between f and d, but we've got this unknown to resolve for, and that's what this boundary condition here will help us to do. So when d equals 2, f equals 12. So if we substitute those values of f and d into this equation, then we're going to get 12 equals k over 4. So in other words, k equals 48. So we can rewrite our equation. This is our fully resolved equation. F equals 48 over d. And then it says find the value of f when d equals 5. So we just substitute 5 in there. We get f equals 9.6 newtons. We will put the units in there. And when f equals 3, then d equals 16. So we can easily work that out. So so that is our proportionality problem. Okay, now this one is this is a frequency density chart. The incomplete table shows information about time in minutes that runners took to complete a race. So it's got these class intervals here, and it's got a number of runners that were in each of those. Use the histogram to calculate the number of runners who took between 40 and 50 minutes to complete the race. Okay, well, yeah, we can sort of work that out. And then it says complete the histogram for the remaining results. Well, what we do is we'll do the whole thing all in one go, and then part A will will fall out from what we're doing. So I've drawn the chart here. Now we need to add some rows or columns. In the case it's rows because of the way it's they've written it, this table. So, and now if what we're actually looking for are the sort of the areas, because the point with these frequency density diagrams, let's just write that in to qualify. The point with these is that the area of each block is proportional to the frequency. Okay, so between 30 and 35, we've got 12. Right. And 20 there. We don't know what this number is yet. But so we've kind of got, when we say it's proportional, it's a little bit like the proportionality problems. We need to know what that constant of proportionality is. In other words, that's like the exchange rate, isn't it, between the area and the number, the frequency. Okay, so let's just complete what we can on here. So when we look at these areas here between 40 and 50 and 50 and 60, well, 50 and 60 is the only one that we've got complete information for, isn't it? Because we've got a block on the diagram and we've got the number of runners. So that is going to give us our constant of proportionality, or our conversion rate, whatever we want to call it. So let's have a look. So that class interval has got a width of 10. It's got a height of 15. So it's got an area of 150. And then if we calculate the area divided by the number, we get this 12.5. Okay, that's 150 divided by 12. Now that 12.5 has to apply right across the board. It's the same conversion rate, it's the same frequency density diagram, so we've got the same conversion ratio. So we can actually fill those in, those red ones there. Right, okay, so now in these cases, this one, and this one, we've now got the conversion ratio, we've got the number, so we can work out the area. Okay, so let's do that. So we've got the area there. So what we're doing is we're multiplying the constant of proportionality, conversion ratio, by the number, and that's giving us the area. Okay, so we do that there and that there. Okay, so now we know all the numbers, and the other thing we need to do then is really just go back and calculate the heights. Okay, well, the width is 5, the area is 150, so the height is obviously 30. Do the same for that and for that. So we've now completed our chart here. Well, we've got the 30 to do as well. So I think what we're saying is that we've got an area of 375 with a constant of 12.5. So the area divided by this is going to be the number. So that's 30. So I think if you just lay it out like this and then go through, you'll always find there's one column in this case, could be a row, depending how it's drawn, that gives you all the information, and from that, therefore, you will know the conversion rate. In other words, the area per count of whatever they're counting. And then that'll give you the ability to actually complete the whole table. So I've written down here, A is proportional to N, so A equals constant times N. So this K is our 12.5. All right, so so that's basically it. So now we know for each of these class intervals, we know the width and the height, and we can just go and calculate them on here. fill in the diagram, and in the process we also know our 30 here as well. Okay, so that is that. It says calculate an estimate of the number of runners awarded silver medals, where runners who achieved a time between 37 and 48 were given a silver medal. Okay, so what we're looking at really is, well, you can imagine. I mean, our frequency. Let's see if I can get the whole thing on the diagram. On the page between 37 and 48. So if we can imagine that these 20 are kind of spread evenly through this class interval, and these 30 are spread evenly through this class interval, then what we're trying to find out is the number between 37 and 48. So, so between 37 and 40, what we're looking at is, well, we've got 20 in here. And we're looking at 37 to 40. So we're basically looking at 3/5 of 20. And between 40 and 48, so 3/5, because 40 minus 37 is 3, and the class width is 5. So we're looking at what's in the last 3/5 of this class interval, and there are 20 in this class interval. It was 12, and the same thing for the next group, except we're looking at 8 here. 48 minus 40, that's 8 out of a class width of 10. So we're looking at 8/10 of 30 in that, which is 24. So that means there's 12 of the silver medalists in this class interval and 24 in this class interval. Now, these are estimates. We don't know the actual number, but we're just assuming that the numbers are spread evenly through these class intervals, and that's what this is going to give us. So the total estimated silver medals is 36. Okay. Right, next question is a recurring decimal question. Show that this recurring decimal equals 8/45. Right. Well, the thing with these is that we need to get the recurring part to be the only thing after the decimal point, and it's got to be the whole of the decimal part. So if we rewrite this as 1/10 of 1.7 recurring, and I've written it as 1 plus 0.7 recurring, because that leads us to the next step, then this 0.7 recurring is 7/9. So we always put it over 9. If there's 2 parts, if it's like 0.73, then it would be 73/99, and so on. In this case, we've just got the 1 digit, so it's 7/9. So 0.7 recurring is 7/9. I've got our 1 here. So if we just rearrange this into a fraction 16/9, then we can now kind of bring this back into the scene. This 1/10, multiply 1/10 by 16/9, and that's going to give us 16/90ths or 8/45. That's how we do that. So the key, as I say, is to scale it like this. Do your workings inside the bracket, and then when you've got it in the right form inside the brackets, then just multiply it out. Okay, so that's got us to the bottom of this IGCSE paper, courtesy of Save My Exams. Hope that's been useful. Thank you.